Welcome back to Calculus with Mr. Walton. Today we're going to talk about Unit 8, which is Chapter 6, Sections 1 through 3. Specifically for today, we're going to talk about Section 6.1, which is slope fields and Euler's method. For example 1, we want to find the general solution to the given differential equation. Alright, so given dy dx is equal to negative 6x squared minus secant x tangent x, let's set this up. Let's integrate both sides. And as a little reminder, the derivative of secant x is equal to secant x tangent x. That might help when we integrate, right? So then we're going to integrate both sides, and we're going to get y is equal to negative 6x cubed over 3 minus secant x plus c. And let's simplify for our final answer. Negative 2x cubed minus secant x plus c. All right, let's look at our next example. Solve for the initial value, or solve the initial value problem explicitly. Sorry that I put that 4 in there. Let's get rid of that, and let's go. We've got rewriting our radical in terms of an exponential form. I like it. All right, so here is our general solution. Okay, remember this is our general solution. And we are asked to find a specific solution. So we're going to plug in our y and x values and solve for c because we have an initial value. So we have 60 going in for y, 4 going in for every x, c is equal to 4. Bingo bango. Now this is our specific solution. And we are done. Okay. So far, I'm feeling pretty comfortable. I hope you are too. And we're ready to move on to example number 3. Bum, bum, bum. Find the slope field for the following equation and then graph the specific solution through the given point. All right. So, you try this right now before I get to it. Ready? Go. Okay, so I have labeled all my points. I have a 5 by 5. I have 25. I've shown my calculations for finding the slopes given what we're talking about. And so then we want to put in all of these slopes to create our slope field. Okay, so if we're starting over here, we're looking at a negative 2, then a negative 1, then a 0, then a 1, then a 2, and then we're talking about it's steeper, kind of matching, then we're still at 0, then we're at steeper and steeper, then we have bam, 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 right here. D and E does not exist. Don't divide by y. So we don't have any slopes. So realize that we might be having to be very careful not to cross this when we're talking about our specific solution. All right, so these are not talking about different little slopes, but say a discontinuity, and then we're moving on. So then we have at 1, we're talking about switching it up now. So we have, this is 4, then 2, then 0, then -2, then -4, and then this is more like -2, sorry, -2, -1, 0, and like this. Then we're going to look at our general solution through the point -1, 1, and hopefully we're going to see that it's going to be something like this and not go any further. All right, let's keep on trucking. Bum, bum, bum. Use Euler's method with increments of delta x equal to 0.1 to approximate the value for the solution. Okay, I'll give you a couple of minutes to set up your chart, and I'll set up mine. All right, you set up your chart. Hopefully you can see that mine just jumped out at you at setup, and let's plug in our values. So for our first dy dx, we get 1. And that means this is 0.1 because we're reminded that over here, bam, bam, delta y is equal to delta x times dy dx. Then let's add delta y to our y so that we get 1.1, and then we know that this one is going to come down here for our next y value. How do we get our next x value? We add our increment of delta x, remember, plus delta x. So when we have this, we should be now at 0.1. Booyah! Then we're going to use calculations to solve our next value. We're looking at 1.22. All right, remember we're going to 0.5, so our answer should be whatever we end up with right here, which is going to be right here. That's what we're looking for. So we will continue our calculations. All right, I am rounding. Use your calculator so you don't have to round, and that would be great. So 1.8371, that's rounded to the nearest 10,000th, and there we go. Hopefully this makes sense. Here is a recap of 6.1.